All right, so you're working with quadratics, and let's first just make sure we know that quadratics is any time we see x squared. So we have to see an x squared for it to be quadratic. And then we were really doing two things. We were graphing quadratics. We're graphing quadratics and we're solving quadratics. Solving quadratics always means whatever over here with x squared equals 0. So we were having some issue when we were practicing it today because you weren't making sure that it equals 0. So when we're solving, we're making sure it equals 0. Well, what does that mean when we're graphing? That means that we're looking where the graph touches the x-axis. So we can have one solution, we can have two solutions, or sometimes it won't touch it at all and we can have no solutions. All right, and first I'm going to do graphing, and then we're going to talk about the different techniques for solving. So when we're graphing, I like to think of these like the three bears. There's very easy graphing. There's very easy graphing, right? There's some medium level of difficulty, and there's harder. All right. Easy is when we see y equals x squared, and we might have plus or minus some value. We'll call that value k, right? We might have some plus or minus because this k is just moving it up or down. So if I have y equals x squared, that means it's sitting right here at 0, 0. And if I said y equals x squared plus 2, that's going to move the graph up 2 and it's going to look exactly the same. And if I said y equaled x squared minus 4, that's going to take this vertex and move it down 4, and then it's going to look the same, right? It's going to have the same shape. The only thing I'm really changing is moving it up or down. Now we can move from this easy, right, into maybe we want to make it be a little bit more difficult, not quite medium yet, but what if we only add a value out in front of that x squared? So now I'm going to change, instead of there being a 1 here, a 1 here, a 1 here, I'm going to change that value to 1/3. And if we do like a little table of values here, if I choose x as 0, well, 0 squared is 0. 0 times 1/3 is still 0. So this didn't change that starting point. But let's say I put 3 in here. So 3 squared is 9. 1/3 of 9 is 3. So now when x is 3, y is just 3. And if I did -3, well, -3 squared is still positive 9 times 1/3, right, is going to be here. Right, so that just made it wider. If I would change this value to, let's say, 3x squared, well, now I wouldn't be growing slowly. I would be growing much faster, right? Because if I put a 3 in here, 3 squared is 9, times 3 is 27. So when x is 3, it's way up there at 27. So what's my kind of rule here? Well, when I have a fraction in this spot for a, so when a is bigger than 0 but less than 1, then it's going to be wider. And when a is greater than 1, then it's going to be narrower. We call that a vertical stretch. All right, and we can change this ever so slightly. And we can just say, well, what if we make a negative? Well, all that's going to do is whatever value we put in for x is being squared, so that value is still going to become positive, but then I'm going to make the y be negative. So when I have a negative, that makes me have an unhappy parabola, but all the other principles really stay the same. So that's kind of easy, right? We add or subtract some value of k, and we put some value in front of x. It can be positive and I have a happy parabola, or it can be negative and I have a sad parabola. So we're going to call that easy, but we need the space for medium. In medium, remember you had something called vertex form, a times x minus h squared plus k. And you can see that this is really the only part I'm changing from the easy part, right? And this is going to always give me my vertex at h comma k. The one thing I have to be careful about is that it's negative in the formula. So if I have something like y equals, let's just make a 1, so let's have x plus 2 squared. We won't, and k, since we don't see anything, is 0. Well, let's see what happens here. When I put in 0, 0 plus 2 is 2. 2 squared is 4. So when x is 0, y is 4. All right, now when I put in, let's say I'm going to put in 2 for x. Well, 2 plus 2 is 4. 4 squared is 16. So, man, it's going up here really fast. I can't even hardly keep it here. Let's say I put negative 2. Well, negative 2 plus 2 is 0. 0 squared is 0. So when x is negative 2, it's over here. Let's go a little bit this way. Let's say I say 4, negative 4. Negative 4 plus 2. So negative 4 plus 2 is negative 2. Negative 2 squared is 4, right? And I could have known that because there's symmetry here. All right, and my vertex is at negative 2, 0 because I didn't add any k there. All right, and that's always going to help you find the vertex. Let's look at one more in vertex form. We'll add some complication to it. So let's say we have y equals 3 times x minus 4 plus 3. All right, so my vertex is at 4, 3, because this is negative, and that means it's moving in the right direction. So 1, 2, 3, 4, 1, 2, 3. Here is my vertex. It's opening up because A is positive, and it's going to grow pretty narrow because of that 3. And I can really sketch those out. I could do a table of values, but I don't have to because I know the vertex and I know it's going to be pretty narrow. So medium is using the vertex form, right? And we know the vertex is always hk. When we see a negative, when we see the negative here with h, it's moving to the right. When we see a positive, it's moving to the left. And the k is exactly how it is. Positive is up, negative is down, exactly what it looks like. All right, I'm going to need more space for hard. Hard is what you were working. I'm going to actually move hard here to the center. So hard graphing is when we have standard form. Y equals ax squared plus bx plus c. And this is what you were working with a lot with this last test. The vertex, x value, is negative b divided by 2a. And the y value is whatever you get when you put that in there. So let's do an example. Y equals, let's say, 2x squared minus 3x plus 4. All right, and negative b, there's a negative here. This is also a mistake you were having. If there's a negative here, the value of b is just 3. 2 times 2 is 4. So that means x is occurring at 3/4. Not such a nice value. If I had to put that in there, I'm going to have, so y is going to equal 3/4 squared minus 3 times 3/4 plus 4. That's 2 times 9/16 minus 9/4 plus 4. If I had more space, I would keep going, or I would use a calculator to find the fraction. I didn't pick very nice numbers, but this is one you saw that I'm working with. So this would give you, let's just keep going. I won't be lazy. All right, so y is going to equal 18/16. I need this to be 16, so times 4 minus 36/16. I need this to be a 4 on the bottom, so that is, or no, I need it to be 16 times 16. 16 times 4, that's 24. 464, so plus 64/16. So 64 minus 36, 5, 8, 28. That's positive, right? And then so I add the 18 here. That's 16, 3, 46. So 46/16, so 16 into 46, what, 32? It's going to be almost 3, but not quite. So x is 3/4, so if there's 1, here's 3/4, and y is not quite 3. It's a happy parabola, So it's opening up, and I can really use this value because I can say when x is 0, this is going to be 0, this is going to be 0, y is going to be 4. So that really helps you find that other point, right? The y-intercept really helps when we graph the hard ones, because the c is always the y-intercept. All right, so that was graphing, right? And what does graphing help us do? Graphing helps us find those solutions, right? This function here, if we said equals 0, I can see from my graph that it never touches the x-axis. So I know that this has no solution. That's what graphing does. Graphing helps us know how many solutions there are, or we can find the solutions. All right, so we said we needed to graph and we wanted to solve. So now we're on solving. All right, and we can kind of think of these the same way. There's really easy solving when I only see x squared. If I have x squared minus 9 equals 0, well, that means that x squared equals 9. The square root of 9 is 3, so x equals 3 and negative 3. If I wanted to connect that to my graphing, this moves it down 1, 2, 3, 4, 5, 6, 7, 8, 9. And it's going to cross the x-axis here and here. Right? And that is taking square roots, right? So the easiest is taking square roots. And how do I know to take square roots? I only see x squared. All right. Well, we can expand this idea when we have the vertex form. So let's say I have x minus 3 squared plus, not plus, let's do minus 9 equals 0, right? And I want to solve this. Well, I can take the 9 over. I can have x minus 3 equals 9, squared. Take the square root. X minus 3 equals the square root of 9 positive, and x minus 3 equals the square root of 9 negative. Add 3, x equals 6, x equals, it'll be plus 3, right? Plus 3 would make that 0, right? And connect it to the graph. This is moved down 9. This moves it right 3. So 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. Vertex is here, crosses the x-axis here and here, right? Connect your zeros to what the function looks like, right? So we have easy, we have medium, and then, and we're still using square roots right here. We can just see that I can simplify this when I have, this is called a perfect square, right? It's x minus 3 times x minus 3. So we can use that idea, right? We can use that idea to kind of keep going. And I want to use, we're going to call, remember you had, this is where we fit in completing the square. And I also want to talk about factoring, because we can always complete the square, and we can always use the quadratic formula. But we want to try factoring first. And why? Because, and these are all things that we do if we see standard form. So this is all on that hard kind of graphing. So factoring, let's say I have 2x squared. I'm going to think backwards here. I'm actually going to start with this so I don't mess up, and then I'll explain what I'm doing. So that would be 2x squared minus 8x plus 3x minus 12. All right, so I want it to be minus 5x minus 12. All right, so that's my, we'll pretend I didn't solve it first, but that I was going. And we're solving, so this is set equal to 0. All right, and the reason that I want to try factoring first is because if you remember from completing the square, you need to take negative b divided by 2a. No, sorry. we needed to take half of, sorry, we're taking half of b. My bad. We're taking half of b when we complete the square. And I'll go over this in a second in more detail. But taking half of 5 is not a nice number, so always check if you can factor. And here, the only way for me to get 2x squared is to multiply 2x times x. So I put those in there first, because that's the only way to get 2x squared. Now, 12, I have some different options, right? 12 is 12 times 1, it's 4 times 3, it's 6 times 2. Right? And I need one of these numbers is going to multiply with 2, and one is in, so I just have to start taking my options, right? If I say 2 times 12, well, that's 24. There's no way I'm going to get to 5 by putting a 1 there. So I can say, nope, that's not going to work, not a good idea. Then my next option is I could put the 3 here and the 4 here. 2 times 3 is 6, 4 is 10. No way am I going to get the 5, so I try it the other way. I put the 4 here and the 3 here. 2 times 4 is 8. 3 times x is 5. That's good. I want this to be negative, so I need more negatives. I need this to be positive so that that is negative. All right, and then I have this is factored, but I haven't solved it yet, right? Solved means I'm setting it equal to 0. So I need to say 2x plus 3 equals 0, or x minus 4 equals 0. In this case, x equals negative 2/3, and in this case, x equals 4. Those are the things that will make it equals to 0. So I want to check, can I factor, then set each of the two factors equal to 0 and solve. All right, but we've seen lots of cases where we can't factor. And this is where completing the square comes in handy. X squared, let's say I have x squared minus 4x plus 9 equals 0. And I look to factor. The only way I get 9 is 9 and 1 and 3 and 3, so there's no way that that's going to work. And so I imagine what I have here is, let's say that this is x times x. And let's say that these are 4, these are minus 4x. And what I'm going to do is I'm going to rearrange. I'm going to put 2 of them over here. I'm going to take the 2 away. And to complete, I want, if I imagine this is a whole square, right? Oops, I don't want so much extra. If I'm imagining this is a square, I need to fill in this part. Right? I have this many extra here, so I have 4 extra. So x squared minus 4x, that's my original problem. The 9, I want to move to the other side because I don't need it right now. And I am adding in those 4. And I can always find this value. This 4 is always whatever b is divided by 2. Now, I'm not just allowed to add 4 to one side of the equation, so I have to add that 4 to the other side. All right, and why is this cool? Is because it allows you to then have a square. I now can factor this. This is x minus 2 squared, and it equals negative 5. Now I can do what I did with square roots. Take the square root of both sides. X minus 2 equals plus or minus the square root of negative 5. That's not really possible, so at this point I can say there's no solutions because I don't get a positive number inside of there. If I were to change this equation, let's make it slightly different so we get a full answer. If I make this minus 9, I have to add it to both sides, so this becomes plus 5, and this becomes plus 5, and all of a sudden now I have the solutions. X equals plus or minus the square root of 5 plus 2. Put it in a calculator if you want, or leave that as your solution, right? That's where completing the square comes in. And you did that fairly well after you practiced it. All right, last one. Somebody very, very clever looked at the process of completing the square and said, oh, this means, when I do this, this means that x equals negative b plus or minus b squared minus 4ac all divided by 2a. They just did the completing the square process And they did that. And there's a proof in the lesson, but you use the quadratic formula, okay. Just remember that the quadratic formula is finding these roots. They're finding when y equals 0. All right, so n is short of a time. That is unit 8 and 9 for you to review.